Okay, so today we're going to be talking about section 7.3, which is multiplication properties of exponents. So far we've talked about properties of addition and properties of multiplication and all these different type of properties, but now we're going to extend this to properties that are dealing with exponents. In this case, what we're talking about today is simply just multiplication properties. There's lots of other different properties, but today we're just going to focus on the multiplication. And all these properties that you'll see, there's going to be 3 of them. So there's 3 properties, and they're all going to be highlighted in some kind of red color. So our objective today is really just to simply use these properties to evaluate and simplify some expressions. First, what we want to do is we want to touch a little bit on what it means to simplify. So when we're simplifying what we call exponential expressions, which are basically expressions that contain some type of exponent or power. And so what we need to do is that we need to make sure that there's no negative exponents, that the same base does not appear more than once in either a product or a quotient. Remember, quotient is division. There are no powers raised to powers, so we can't have something that's raised to 2 different powers. No products that are raised to powers. No quotients raised to powers, and coefficients in a quotient do not have any common factors other than 1. So basically what that really means is an example of this last one is right here. So really this is saying this is 5 divided by 2. Well, you can't reduce that any further, and that's what they're talking about. So here we have examples and non-examples. Obviously the non-examples are things that we don't want to look at, where 10 over 4, remember that can be reduced to 5 over 2. So that's why it's a non-example. And then you can look at all those other ones and look and see what is simplified, what is not simplified. So that brings us to our first property, and our first property is the product of powers property. Product of powers property. Basically what this is going to tell us is that when 2 powers are multiplied together and have the same base, all we need to do is we need to add the exponents. So let's look at these 2 quick examples here. The first one, we have 6 to the power of 7 times 6 to the power of 4. Remember, 6 is our base, and in this case what we have is we have our exponents, which our exponents are 7 and 4. So if we have the same base, all we have to do is we have to write the same base again. So this is 6, and then what we can do is we can add our exponents, which are simply 7 plus 4. And so what this does is this then becomes 6 to the power of 11, because 7 plus 4 is 11. Now the way that we know that this is true is because we can say, first of all, that 6 to the power of 7 really means 6 times 6 times 6 times 6, 7 times, times 6 times 6 times 6 times 6, which is 6 to the 4th power. And if we multiply all those together, what we really do is we have 11 of these. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's how that really works. And if we don't have numbers, and we just have variables, what we can simply do is we can just say, okay, well my base is A, exponents m and n. So if we don't have any numbers to write, all we have to do is we have to say our base, which is A, to the power of m plus n. And that's all we have to write, because we don't know anything else. And if we knew anything else, if we knew what A was, or M was, or N was, what we could eventually do is we could just eventually simplify that. But this is as far as we can go with this. Okay, so now we're going to look at examples of using this power, or this property. And so what we're basically going to do here is we're going to start and we're going to look for the same base. So in order to use this property, we need to have the same base. So let's look at this first example. 2 and 2. Is that the same base? Yep. Okay, so then we can write it, 2. And then we look at our exponents. We have 5 and we have 6. So really all we have to do is add those together. So 5 plus 6. And so our resulting answer is then 2 to the power of 11. That's it. Alright, let's look at our second example. Now, we have different bases. So what we're going to do is we're going to look for bases that are the same. So we have this, and this one, and this one. You might have already spotted those. Now remember some of our earlier properties. That says we can multiply in any order. So what I can really do is I can rewrite this problem, which is what I really want to do, and get everything close together. So we have 4 to the power of 2 times 4 to the power of 5. That's one separate thing. Times 3 to the power of negative 2 times 3 to the power of 6. Okay, so there's that. Now, I added these parentheses because you should know that this is the associative property, that I can add parentheses and multiply how I want. So I can take this piece by piece. Because the reason I can't use our new product or power property, the product of a power, is that these do not have the same bases. We have 4 and we have 3. And so we can treat these as two different things. So the first one is they have the same base of 4. So I have 4 to the power of 2 plus 5, which is 4 to the power of 6. And that's still being multiplied by this piece, which is base of 3. And now some of you are thinking, okay, well, I see this negative 2 power. I need to take the reciprocal. But hold on. Because we're adding, what we're going to do is we're going to say negative 2 plus 6, which gives us 3 to the power of 4. And so that's our final answer. And we didn't have to worry yet about the negative exponent and sending it to the denominator and all that stuff. What we can do is we can wait until we're all finished and then see what we need to do. So our final answer here is 4 to the power of 6 times 3 to the power of 4. Now what I could do is I could put that into my calculator and get a final answer. But our last example deals with, okay, well, what happens when we don't have any numbers? So I look at this and I say, okay, what are my bases? I have a y, y, and a y. And so now I can say, okay, well, my base is y, and so I can say 2 plus negative 4, right? Well, what about this y right here? Now we talked about this before. What is the imaginary exponent here? This is y to the power of 1. So then I need to add one more. Okay? So I say y, 2 plus negative 4 is negative 2, plus 1 more is negative 1. Now remember, the rules of simplifying say that I can't have negative exponents, so then I can say that this is now 1 over y. Because remember, this negative 1 exponent really, in a way, means reciprocal. Okay, and that brings us to our next property, which our next property is a power of a power property. So a power of a power property. So basically what this says is that when a power is raised to another power, it equals the base to the product of the exponents. So basically product means multiplication. And so let's take a look at some of these examples. So if I'm taking it's equal to the base raised to the product of the exponents, what we need is we need to say, okay, first of all, my exponents we're going to label in green. So my base, we should know, is 6. So let's write our base, 6. It's the raised to the product of the exponents. So my exponents are 3 and 4 in this case, because the way that we say this is that this is 6 to the 3rd power to the 4th power. And so what we can really say is, if we remember what we know about exponents, is that's writing this 6 to the 3rd power times 6 to the 3rd power 6 to the third power times 6 to the third power. And then we can go through this long drawn out process of saying this is 6 times 6 times 6 times 6 times 6 times 6, and this is just getting way too ridiculous to write. And so what we can do then is we can come up with this rule and this property that says all we need to do is we need to take our exponents and multiply them together. So 3 times 4. And so what this is going to give me then is this is going to give me 6 to the power of 12. And we could go through there, and if we look at this, we could go through all that whole thing, and we know now, based on our last property, what's this? We're adding all these up, right? So 3 plus 3 plus 3 plus 3, well, yeah, that equals 12. So we know that's going to work out. And our last example, again, before we move on, is showing us things without numbers. And so if we do the same process, we write our base, which is a, so that's our base. Our exponents are m and n. And so in order to write a product of these, all we have to do is we write m times n, or n times n. It doesn't make a difference. And so our final answer here simply is a to the n times n, because we don't know what these numbers are yet. If we knew what these numbers were, then we could go ahead and finish. But we can't, so we're just going to wait. Okay, so on to some examples. So if we follow our property that says we take the base and then multiply our exponents, so in this case our base is 7, so 7 is our base, we write our base, 5 and 2, and so all we have to do is we have to multiply 5 times 2 and use that as our exponent. And so what we end up with is we end up with 7 to the power of 10. Pretty easy. Alright, let's look at our next example. So our base is 3. Our exponents are 6 and 0. And we have to multiply these two together. So we get 6 times 0. Some of you are thinking, okay, well, that's really just going to give me 3 to the power of 0, because we know that anything times 0 is always 0. But when we get along to this, what is anything to the power of 0? Well, that's just 1. So although we had to do all this work, really we ended up with our answer being 1. And if we look at our last example, now what we're going to need to do is we're going to need to use our ideas and really kind of start to include these a little bit more. So what we need to do is we need to think about our past properties and kind of think about stuff that we need right away. And think about our orders of operations. So first of all, let's look at this piece first, because this has the most exponents. So I'm going to deal with this one first. And so if I deal with this one first, what I'm going to end up with is I'm going to say my base, which is x, my exponents, 2 times negative 4, and then I still have this times x to the 5th power, but we're going to wait on that. I continue down. I'm multiplying these together. I get x to the power of negative 8 times x to the power of 5. Now I use my product of powers rule that says if I have the same base, which I do, I add my exponents, and so this becomes x to the negative 8 plus 5, which is x to the negative 3, and by now we know that this is really 1 over x to the 3rd power. Okay, if you didn't quite catch that, there are some examples that you can look in the guided practice section that kind of step you through that. But what we need to do is we need to take pieces at a time and just work with one piece. Use the properties that we know. Okay, we can't really use anything like this together at one time because we have different things going on. And the same thing goes along with the order of operations. If we don't use our order of operations correctly, we're not going to get it correctly. So always start with, in a way, what has the most exponents. Okay, and that brings us to our last property. Our last property is what they call power of a product property. And what this is saying is that when a product, or the multiplication of a couple of different things, is raised to a power, it equals the product of each, what we call factor, raised to that power. Raised to that power. So we kind of touched on this before in our last examples, or our last section, and so we're going to go into why this really is. Okay, so if we look at this first example, we have 2 times 4 to the power of 2. Now, most of you would say, okay, well, really, if we just simplify that, that means 8 to the power of 2. And what is 8 to the power of 2? Well, you would tell me is 64. Now, let's use our power of a product property, which tells us, in a way, what we're doing is we're taking this exponent right here, this power, and we're, in a way, giving it to each piece. So this is kind of a distributive property, but we don't call it a distributive property. This is what we call power of a product property. And so what we end up with is we end up with 2 to the power of 2, still multiplied together by 4 to the power of 2. Okay? So we kind of gave each term, or each factor, so these are our factors here. These are our factors. So we gave each factor that same exponent, which in this case was 2. So if we actually do the multiplication here, 2 to the second power, you know, is 4 times 16, which is also equal to 64. And hey, that's exactly what we got here. So really, these still work. But what we really use this property for is when we don't know something, when we don't know these values. So what we need to do here is, again, we need to use this same property and say, okay, I'm taking this power and raising it, or each one of these factors, and raising it to that power. And so I have a to the third power times b to the third power. Now my rules of simplifying say I can only have the same base occur more than once. Okay, I don't have the same base here, so I can't really simplify this any further. So this is all we have to do. So like I said before, the power of a product property is generally used when we don't know certain values. And we're going to look at some examples too as well. Okay, so my first example, what we have here is we have something a little bit tricky. Now, we're always going to deal with something with negatives here. So we need to be able to rewrite this for something that we can understand. So what we have here is we can rewrite this. Remember, this is always having an imaginary 1 out in front. And so we can rewrite this as negative 1 times 2y to the second power. And if I use my property, this thing is I take my 2 and raise each term to that same power. Now notice that it's not going over here to this negative 1 because it's outside of the parentheses. So when I rewrite this, I get negative 1 times 2 to the second power times y to the second power. And I can simplify this continually and get negative 1 times 4, since we know what 2 to the second power is, times y to the second power. And then I end up with negative 4, because I can multiply this, y to the second power. My next example, same thing kind of happens, but a little bit differently. Notice our negative is now on the inside. And so really what we're doing is we have two terms here. We have a negative 2 times a y. And so I raise each one of those factors to the power of 3. So I send this over here and here, and so I get negative 2 to the third power times y to the third power. And then so we can finish this and say that this is, well, negative 2 to the third power is really negative 2 times negative 2 times negative 2, which gives us negative 8y to the third power. And then now what we have is we have another problem here. It's just a little bit different. Now what we have over here is I'm going to add a little bit more space. Now think of these as being, using the same rule, think of these as just being some number. So we're going to cover these up for a second. Let's say that this was A and this was B. How do we approach this problem? We would say that this is simply A to the second power times B to the second power, right? So how is this really any different? And so what we can do is, what's A? Well, if I told you A was x to the sixth power, what this would really become is this would be x to the sixth power, because how do we substitute? We substitute with parentheses to the second power, and then times that by B, which our B in this case is y to the negative 3 power, and so we get y to the negative 3 in parentheses with a 2 on the outside. And then now what we can do is we can use our other properties to help us solve this. And so whenever we see something like this, we should automatically think power of a power. Think power of a power, and what do we do with the power of a power? We're multiplying these two things together. We're multiplying the exponents. So we have x to the power of 12 times y to the power of negative 6. Okay, these two bases are different. Okay, I can simplify this. How do I know I can simplify this? Well, I have this negative exponent. And so what I can do is I can just send this to the denominator, make this one big fraction, and send this to the denominator. And then what I get is I get x to the power of 12 over y to the power of 6. Now if we go back to this problem, what happened? Well, what really happened here is at the very beginning we can go all the way back, and with this 2, if we see any other exponents like this, we could save ourselves some work and just do simply what? Well, we could multiply. So we say 2 times 6, which is 12 down here, and then negative 3 times 2, which is negative 6 down here. So there's different ways that we can approach this problem, but we'll always get to the same answer. Okay, so there's those three problems. And that's pretty much it. What you can do, if you would like to, is that you can try number 11 and 17 in the guided practice section of your book. Now these are a lot more difficult, and just so a reminder, it's okay if you don't get it right. Just remember to use all your properties. And remember, start with the most exponent. And then kind of work your way from the outside in. Just kind of like what we did with our order of operations. So think of order of operations when you're doing these. And that'll be it.